Frames are a different way of thinking about the same idea as relative velocity. To say that, for example, say I write that car A is going at 12 meters per second, positive 12, relative to car B. You know, in our symbols, that means velocity of A relative to B is plus 12 meters per second. Another way of saying this is that car A is going at plus 12 meters per second in the reference frame of B. So these are all equivalent statements, right? And reference frames, oh, frame got cut off, oh well. To think about reference frames, it's helpful to think about the symbols, okay? So let's think about this. Let's say that we've got two cars, or two people. Okay, there we've got person A. Say we've got person B. Okay, and let's say person A is moving at plus 2 meters per second relative to the ground. Let's say person B is moving at minus 5 meters per second relative to person A. Okay, now we could use our rules and put them together. We could, think of it in terms of relative velocities, but let's talk through how we would think about this in terms of reference frames. Okay, let's say I want to find the velocity of B relative to the ground. Okay, well, we have the velocity of A relative to the ground. Okay, and now this is very obvious. The velocity of anything relative to itself is 0. Okay, but this is kind of an intermediate thought step. You don't have to write this down once you get a handle on how this works. But the velocity of the ground relative to itself is 0 meters per second. Obviously, right? We have B relative to A. The velocity of the ground relative to itself is 0, but what's more relevant at the moment is the velocity of A relative to itself is 0, because we have the velocity of B in the reference frame of A. We want it in the reference frame of the ground, and so now we have the velocity of A relative to the ground and the velocity of A relative to itself. So this allows us to figure out the transition between the ground reference frame and the A reference frame. So to go from ground to A, what's the difference there? To go from 2 to 0, that's a difference of minus 2. So to go from velocity of B relative to A, velocity of B relative to G, it's a difference of minus 2. So the velocity of B relative to the ground is minus 7 meters per second. Okay? Let's do another example here. Say you've got person A, person B, person C. These are beautiful people, I know. My artistic skills are unfathomably amazing. Let's say that person A is going at plus 2 meters per second relative to person C. Let's say that person C is going at minus 1 meters per second relative to the ground. And let's say that the velocity of person B relative to person A is, I don't know, it doesn't matter, minus 3 meters per second. Okay, and let's say I want to find let's first find velocity of person A relative to the ground. Well, what is it that we want to do? We want to go from the reference frame of C to reference frame of ground. So how do we do that? Well, velocity of person C relative to person C is, of course, 0 meters per second. So to go from reference frame C to reference frame ground, the difference is -1. So velocity of A relative to ground, if you go from C to G, difference is -1. So that is positive 1 meters per second, 2 minus 1. Let's say I want to find velocity of person B relative to person C. Well, we want to go from reference frame A to reference frame C. We have the velocity of person A relative to C. I'm just rewriting this because things got kind of scribbly up there. Velocity of person A relative to person C is 2. We want to go from A to C. Velocity of person A relative to person A, of course, is 0 meters per second. So going from A to C, difference is from 0 to 2 plus 2. Plus 2. So velocity of B relative to C is -1 meters per second. Let's say I want to know velocity of person B, or the velocity of the ground relative to person B. This always kind of throws people. You know, the ground isn't moving, right? Well, we tend to think of it as stationary, but relative to this person who is moving, the ground is also moving. So, velocity of ground relative to B. Okay, well, we want to go, we don't have the velocity of the ground directly, but we do know velocity of A relative to the ground is 1, which means the velocity of ground relative to A is just the opposite. That was our first rule. So now we have ground and we have A. So we want to go from reference frame of A to reference frame of B. And we can use this. Velocity of B relative to A is -3 meters per second. Velocity of B relative to B is, of course, 0 meters per second. So to go from A to B, it's a difference of +3. So to go from A to B, that's a difference of +3. So velocity of ground relative to B is +2 meters per second. So that's kind of the idea of how relative velocity works. In class, I'm going to take some time to go through some problems and see if you guys can figure it out, and also to do a little bit of this in 2 dimensions. But hopefully that gets you the basic concept, and we can go from there.